Hey guys, welcome back. Satyam here from Codezilla, and today we'll be doing one more algorithm problem, that is insertion sort. So we'll be doing step by step how we can approach the problem, how we can show it in an interview or whatever, whenever you want to show that. So now let's start working on it. So as in the previous videos, I will be doing it in same way. So as previously I have told you about the bubble sort, then the selection sort. Both of these algorithm work fine. Like then why do we need insertion sort? So uh, as I have told you earlier only, like in selection sort, the time complexity will be big of n square. But for the upcoming one, that is our bubble sort, it will be big of n square also. And I will tell you one more thing. Insertion sort, it will also be have big of n square time complexity. N square, n square, n square. All three cases have time complexity of n square. Then why do we need it? Like what is the need of having two more algorithms? If we know selection sort, then why bubble sort and insertion sort or any of them? The thing is the optimization which we do in each of them. Like in selection sort, it is for all three cases, for best, for worst, for optimal. All three cases, like for the best and all three, it will be big of n square only. But in the bubble sort, as in the previous one only, we do some tweaks, and after that it become optimized for some of the cases, because when it get sorted, after that we didn't do we didn't run the other upcoming for loop. We just break from there. So if we have a array which is already sorted, then it will be giving us time complexity of big of n. That is for sure. Now in insertion sort also, we will be doing same thing. Big of n square will be the time complexity for sure. But we will be doing some tweaks, or the code in which it is implemented will be helping us to make it optimized for few of the cases. Although for the worst one it will be n square only, but it is better than the two of them. So that's how we just went on a graph. Like firstly on selection sort, this much time complexity, then we in bubble sort same, then some tweaks, some more time complexity, they get decreased, then insertion sort, then again some decrease. In this way the time complexity chart will be on the like more optimized way. So if we take it as an optimization, so it will be increasing. And when we go to the merge sort and uh, like quick sort, then it will increase and then become constant. That is big of n log n. That is like in upcoming classes. So firstly, now let's understand the insertion sort. Insertion sort. So in insertion sort, it is like we will be iterating in the array, and we will be solving that sub portion in which we are. Simple. So if we have an array, and this array is like having values like 2, 8, 1, 3, 9, 10, and like 46 or 14. Let's take. Now what we will be doing, we will be iterating in the array one by one. Firstly taking this portion, this, 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 and this. So what we will be doing, in each of the portion we will be sorting that thing. So here there is there any need of sorting it off? No. Here when 2 and 3 sorting needs, no. Here when 1 came, then we have to sort it in this order. We will be sorting it off with the help of a while condition. We will be discussing in the further. 3 will come, Then we have to sort it again. 1, 2, 3, 8, 9 came. We didn't have to sort. Just go. 10, same. 14, same. We didn't have to sort. But the steps are we have to sort at certain steps and we will be doing it. And the thing is, only when we have to sort some values, then only will be the nested loop will be working. Otherwise, it will not be implementing because we can use a while loop there so that whenever the situation happens when we have to sort previous things, then only we will be doing it. Otherwise, we will not be. Now let's uh, go to the code and then try to implement it and see how we can do this. So I will be going to any of the C++ compiler. This is an online compiler. I have pre-written like selection sort and bubble sort, which I have told in the previous videos. Now we will be doing the insertion sort. So void insertion. As in the previous videos, I have already told you about the vector int and prr intent, which is the size. Okay, let's correct this to this. So as in the selection sort, we know we will take the minimums and place it as a, and in the beginning only. Bubble sort take the maximum, place it at the last. But when we have to do it for the insertion sort, then then we have to like sort the specific sub portion in which we are already. So now let's implement that, how we will be doing it. So for selection sort, firstly a loop is for sure needed for loop from int I equals to 0 and it should be running till and I will plus plus. This is the first loop which will be taking our portions one by one. Now inside this we will be writing a while condition which I have told you in the intuition only. So what we will be doing in the while condition is uh, firstly the condition is let's take an pointer firstly j because we will be using a while condition, so for iterating it we need a pointer which will be pointing towards I in the beginning. Now while our j is greater than 0, that is for sure, and our arr of j means the present element which we have is is smaller than arr of j plus 1. In that case, we have to do the swapping and all the stuff because if we take this situation only, if we take this case, let me show you this case. So if we take this case of insertion sort and let's see. So if you can see that in this specific condition which I have written, the while condition if I have written, so in the array which we have right here, so 2, 8, 1 and 3. Let's take this sub portion only. Okay. So what happens? J will be pointing towards the I. So if we are when we are at the first position, there is no sorting will be happening. Second position, there will be no sorting happening because the case will not enter in the while condition because we have written the and condition, and condition says that when ARR of J means when our I is at 2 means we are at this where we have to do sorting. At that condition, ARR of J means I and ARR of j plus 1. So we have to take this into minus 1 actually. We have to see for the previous one. ARR j minus 1. Okay, minus 1. So we have to do it minus 1. Now what will happen? If our 8, like here is the case, when our ARR of j minus 1 equals to is 8 and ARR of j is 1, then what will be happening? It will be passing the condition of while j is greater than 0, sure, and along with that it is greater. So we have to swap them in order to make our array portion, that sub portion, into an sorted one. So what we will be doing is we will be going here and then we will be applying a swap condition. Swap will be of ARR of j and ARR of j minus 1. Swapping them off. Now in the next condition, what will be happening? We will be entering then again. Then we have to decrease the j. We will be decreasing the j minus minus. Now j will become 1. So ARR of 1 and ARR of 0. Now according to this, now we have already swapped. So means this will be becoming 2, 1, 8 as of now. And this will be at 0th index, 1 index, 2 index. Now we have to take this. ARR of 1 is 1 and ARR of 0 is 2. Means again it satisfies the while condition. It is again greater than it. So we have to swap again. So we will be doing swap again. So what we have to do is we just have to decrease the j. J will get decreased. And that's how the implementation is done. Then we at the end we will be just returning because it's a void function. So we will be swapping them and we will be returning it. So now let's firstly try to implement this insertion sort and see if there is any error occurs or something else, then we will be solving that off. Yeah, so no errors. So firstly we will be taking this and taking the array which we have initialized earlier only, 2, 8, 1, 3 and 40. Here you can see that it is in sorted order. So implementation of insertion sort is also perfectly done. The portion which we will taking, the sub portion which we have to take care of that thing only. And the optimization which I'm talking about is we will be iterating in a loop, but just take a case when the whole array is already sorted 1, 2, 8, 12, 13. It will be for sure pointing, j pointer will be pointing towards each of the value, but will it enter in a while loop? No, because none of the case will be there in a case like whenever our ARR of which is greater, like if j pointer is at 12, so it will point and the j minus 1 will be at 8. So this condition is will not be satisfied, it will not enter in the while loop. So it is an optimized step which we have taken, optimized pointer we can say, which will be optimizing our solution. So in an like if we have an array which is already in sorted order, then big of n will be the time complexity. Otherwise, the time complexity, if we have to take in a like bigger bigger case or bigger picture, then it will be for sure big of n square only. Because we are having two and we have to iterate in the worst case. We have to take for the worst case for sure in the interviews. And for the space also, we have to take space complexity in the like it will be constant big of 1. So that way the optimization and all the stuff work in this specific time complexity chart and in our insertion sort. Algorithm has been implemented and it is working fine. So that's all for the video. Thanks for watching it. I hope you liked it.